Hello everyone, I am Siddharthan. In this video, we are going to do something really exciting. We are going to run a large language model directly on a Raspberry Pi using Ollama. No cloud, no API keys, no dependencies. Just pure offline AI running on a tiny board. I'll show you the complete process in a step-by-step way from SSH into the Raspberry Pi board, installing Python and virtual environments, installing Ollama, pulling the models and running it with a Python script to stream responses in real time. This is super useful if you want to build edge AI applications like smart home automation, IoT assistance, robotics, or offline inferences, and or fully private AI systems where it doesn't even connect to the internet or something like that. This is also will be helpful when you want to deploy something on a server. So let's get started and turn your Raspberry Pi into a powerful mini AI device. So here I have a Raspberry Pi 5 board that I have ordered like a few months back. So you can just like check this out in raspberrypi.com products, Raspberry Pi 5. Just like do a Google search, you can like find this official site. So you can just like look at the different features of it. So it comes with like two HDMI ports and all that. So like there are like a bunch of features that you can play with. It's more of like a mini computer. You can think about it this way if you haven't like used it before. And I think a lot of people would have used this in their college projects, college final year projects. I bought this particular version, so Raspberry Pi 5 with like a 8 GB RAM, so that I can just like run some Ollama models. Again, we cannot run like very large models, but the smaller models we can definitely run. So this is the one that I'm using. I think this was the cost for which I also have bought like couple months back. So just like check this out if you are interested. Again, if you have one already, you can use that as well. So this is the first step. So let's consider that you have a Raspberry Pi 5 board, and the next step would be for you to set this up. So I'm not going to talk about the OS installation and all that. There are like several tutorials that are available. uh, Simplest way, go to Google and search for setup Raspberry Pi 5. You will see this getting started Raspberry Pi documentation. So it has like all the process, like with this YouTube demo and all that. Just like follow this. It would be better if you have a display, keyboard, and a mouse, but there are also ways like where you can just like uh, do the setup without any of this. So that is also possible. Just make sure that when you are installing it, you are enabling SSH. So the process is like you would plug in a SD card or a pen drive into your system. It can be like a Windows or a Mac OS system, and then we have to kind of flash that with this Raspberry Pi OS. You can use Ubuntu or other OS as well, but Raspberry Pi OS is more of like optimized for it, so you can just like go with that itself. So I'm using a Raspberry Pi OS on my board. And once you're doing this setup, there would be this edit settings option where you can customize this. So like you can just give your Wi-Fi credentials, so that when you start your Raspberry Pi board, right, once you connect power supply and start it, it will automatically connect to the Wi-Fi that you have set up and all that. And here you can just like give all those details, host name and other stuffs. The important thing is in services, you can enable SSH, because I'm going to access the Raspberry Pi from my Mac OS device that you're seeing here from the terminal using SSH. So I would just like mention the IP address of the device and I will like connect to it. So these are the prerequisites. So just like install the OS in your pen drive or your SD card. Make sure SSH is enabled, Wi-Fi is there and all that. And then you can just like get started. Okay. And yeah, so now let's maybe start with the process. I'm going to open my terminal. Let me expand this. So let me just like zoom this a bit that it's easier on the eyes. Okay, so now I'll say SSH, and the username that I've created is this SIDDH at 192.168.1.16. So this is the private IP of my Raspberry Pi board. And then make sure this device from which you are accessing it and the Raspberry Pi both are connected to the same Wi-Fi network or LAN, because this is like a private local network that we are accessing it. So you can just like access it. This is the IP address for my Raspberry Pi device. Yours can be different. So what you can do is, once you installed your sorry, OS onto your SD card and plugged it with the monitor, keyboard, mouse and all that, right? So you can just like start it, and you will see an the terminal option. Basically, you can open the terminal in your Raspberry Pi board. One second. Okay, so it's considered that you have installed Raspberry Pi OS and plugged it into one of the displays, and you're connected mouse and keyboard. Okay, similar to your Ubuntu and all that, you will see like browser, a very simple browser under terminal window as well. So open the terminal, and in that terminal you can run something like this: host name space hyphen capital or uppercase I. So this is going to give you the IP address. So this is the address that I am using. Okay, so 192.168.1.16. So you will see like something like this, and this is what you have to do to connect to it. All you need is this. After that, you don't need to connect your Raspberry Pi to a a monitor, keyboard, or mouse. You don't have to do it. All you need is find this IP address, make sure that it is connected to your Wi-Fi network. That is all that we need. So now once I find this right, so this is my Mac OS terminal user, and here I have to log in. So I can say SSH space, note the username that you have configured, and say SIDDH. This is my username, and I'll say 192.168.1.16. You can also find this in your router settings as well. So it would show you like the list of devices connected, and what's the IP for that as well. So I'm logging in. So here you have to give the password that you have set up for this user on the Raspberry Pi board. And then here you can see Siddharth or Sid at Raspberry Pi. So I'm currently logged in into my Raspberry Pi board using SSH from this terminal. So let me clear all this. Okay. So now let's follow the process of how you can install Ollama, pull the models, and run it with a Python script. So this is the process that we are going to follow. So the first thing that we have to do is install the required softwares. So in Raspberry Pi OS, I think Python will be already pre-installed, but you can also check that if your virtual environment is installed. So what I'm going to do is say sudo apt update. So this is going to update the packages, update like the list of packages. Sorry, it should be sudo update. So let's run this. So this will refresh like all the packages, and then we can install the package that we want. So I'm going to install Python virtual environment. This is because let's not run our Python script. So we are going to call or load the Ollama model from our Python script, send a query, and get a response. Let's not do that on the system's Python. Let's create a virtual environment so that it doesn't affect any system level files or like system level libraries and all that. So for that, we need to install virtual environment. So we can say sudo apt install python 3 -venv space -y. So this -y is just like a yes confirmation, that is all. So note this command: sudo apt install python 3 -venv -y. Okay, you need to run this sudo apt update before this and run this. So this should already be there. So it says that. If not, like this command will like install it for you. So that is the first step. So as you remember, so the first step is installing virtual environment. To check the Python version, you can say python 3 space hyphen version or something. Or I think you can also say Python version. Sometimes it won't like address, or it won't recognize if you don't put this 3 here, but in this case it does. So that's all good. So the next step is installing Ollama. It is like pretty simple. So search this in Google. Install Ollama. So Raspberry Pi OS is a Linux based distro. So you need to go to this download Ollama on Linux page. Okay, so not the Windows or the Mac OS, and you will see this curl command. So copy this command and paste it over here. So this is going to install Ollama in your Raspberry Pi board. So this may take some time depending upon your internet speed and all those things, but I've already installed this. So I'm going to just like stop this process. As I said, it's already there. I can check this by saying Ollama space double hyphen version. So it says like the version is 0.12.11. Okay, so come back to this browser. Okay, so all you have to do is run this curl command that you see in this download Ollama. So the next step is pulling a model, right? So I already have like a couple of models over here. I'll say Ollama list. So I have like Gemma 2 billion and Gemma version 2 billion. So these are like pretty smaller models, as this Raspberry Pi. This comes with 8 GB, but I wouldn't recommend like running very large models, as this can be heavy on the system. So just like make sure that you are running like smaller models on it. Okay, so I have like these two models. If you want like other models that you want to use from, you can just like check this in this models page, or just search for Ollama models in Google. So it would take you to the library. Here you can just like check, you just like choose a smaller version, maybe 2 billion models, 4 billion models, and something like that. So I'm just going to go with this 2 billion. If you want this Quen model, you can do that, or DeepSeek or any other small models you can run. I'm going to just like go with Gemma only. Okay, so that's the idea. So let's say we want to pull Gemma. I'm going to search for Gemma 2. Click here, and here you will see a command Ollama run Gemma 2. So this will pull the model and automatically run it. So let's say that we just want to pull it, but we don't want to run it. So these are the sizes. We have like, we can run this 1.6 GB, which is a smaller model. Copy this name, which is Gemma 2 colon 2 billion. So here I have to say Ollama pull Gemma to 2 billion. So run this, and as I already have the model, this is not going to take me time, but yeah, for you it will like download this 1.6 GB of models, and once you have pulled the model, when you run this Ollama list, and that's going to list the models that you have. Similarly, like how we would work with Ollama on a Linux or a Ubuntu machine. And if you want to run this, you can say Ollama run space the name of the models. I'm going to say Gemma 2 colon 2 billion, and I'm going to add another parameter called as double hyphen verbose. Verbose lets basically to know, what's the time taken to get the answer, what's the tokens per second that the model is generating, and so on. So this helps us to understand the performance of the model as well. So you can just run this Ollama and Gemma 2 billion also, but it wouldn't give that verbose, but you can include this verbose to get like the finalize the performance numbers and so on. Let's wait for this model to start. And other thing, just keep your Raspberry Pi board closer to your Wi-Fi modem, or maybe best part is connected with the Ethernet cable, because I've noticed that it is not that good. So the Wi-Fi drivers are like, was not like that good. So my Mac OS is in a different room and it connects to the internet well. The internet speed is good, but when I just like have it near it, which is like a bit far from the Wi-Fi modem, it's not working well. So right now the Raspberry Pi is in a different room where the Wi-Fi modem is. I just wanted to make sure like the internet is better on it. So that's the reason. So make sure that it is near to the Wi-Fi modem or just connected with the Ethernet cable. The idea is it won't be the Wi-Fi connector in your board won't be that strong when you compare it to a computer or your mobile device. So that's one thing. Okay, so this model has started. Now I'll just like ask a simple question like why sky is blue, right? So now we can see the response that is being streamed. So this is actually like pretty good. It's not, the latency is not like that much, right? So we have a parameter called as like time to first token, TTFT. It is like what's the time taken for the user to see the first token, and here it's pretty kind of less. So once we send the question, within like maybe a second or two, we kind of saw the first token. So it's like pretty good for this smaller model. Of course, we won't be able to run like large models, and large models can also be like slower as well, but this is like pretty good for a Raspberry Pi board when you want to like run something. The idea for using this is, right, think about building your virtual assistant, so it will always be running. And let's say you have connected a mic to this Raspberry Pi board, and you have a virtual assistant code. So when you just like Alexa, right, you can just say a wake word, and it's going to turn on, and you can just ask a question, and it can use like one of the local models with Ollama or Llama CPP and all that, and it can answer this. So you will like basically able to do that. So those are like the advantages of like using this Ollama over here. You can see the total duration it taken is like 42.5 seconds, pretty good for this response. And also we have streamed it, so it was like a good user experience as well. If we just like got the entire response and then printed it, it would have been like a bit slower, but this is good, I would say. So we have like all the counts, eval count of 281 tokens, prompt eval rate is like 12.93 tokens per second, which is like pretty good, I would say. And then we have the eval rate as 6.90 tokens. So this is basically given by this verbose parameter. Okay, so to close this, type in this /by, and that's going to kind of like stop this session of running this Ollama model. Okay, so this is the basically the process of how you would install Ollama, pull a model, and you can run it. So now what we are going to do is create virtual environment as like maybe one of the projects, and write a Python script, and that Python script is going to basically send a query and get the response. So this is what we are going to do. So I'll do a ls. So this is going to list all the files, or sorry, the files in the folders that is present in this home directory. So in my home directory, I have my desktop documents, download music, and so on. So this is basically a computer, Raspberry Pi. It's just like a mini PC, I would say, as I've already mentioned. So instead of just like creating a virtual environment here and all that, let's just have things organized. I'm going to create a directory. For that, you can use mkdir, make directory command, and I'm going to name this as projects. So all the projects that I'm going to work on this Raspberry Pi, I can include it in this projects directory. Okay, and now when I do a ls, you will see this projects directory that is being created over here. Now I'm going to access this projects directory. So I can say cd. So this is going to navigate me into this project directory. You can press tab, that will auto complete it. So I've typed in pr1, I'm pressing tab and it will auto complete it. And this folder is empty, right? So now I'm going to create another directory. It's like kind of subdirectory. So project is like the parent directory, and within that I'm going to have multiple projects on my Raspberry Pi board. So that is the idea. They'll create another directory and I'll call this as 099, just some serial number for my projects, as I'll definitely be using this for other projects on YouTube. So I'll say make directory 099 and Ollama. You can give any name over it. It's not mandatory that you should give that. I'll call that Ollama Raspberry Pi. Okay, so this is my project. And similarly, I can navigate here 099. I'm pressing tab and I would access this. Again, do a ls, it would be a empty directory because we have created it that way. So now we have to create a virtual environment. Just if you're not sure what a virtual environment is, when we work on a project or a use case, right, it's better to create a virtual environment. And virtual environment is, think about it as like the place where all your Python library is going to be saved. And why it is important, so think about it, right? So your Raspberry Pi by default as, let's say, a NumPy version of X, but your project needs the latest version, which is NumPy version Y. So this is the case. You don't want to affect it, right? So you would create a separate virtual environment or a separate container in which your the specific project can run. So each of your project would have like a separate virtual environment and you would run it there. It's not just for Raspberry Pi, it's like a best practice, like wherever you work, it can be your personal computer and all that. So we would always create a Python virtual environment, install the libraries required for that project in that virtual environment. There is a case like one project requires one version of a library, other project requires other version. So that is the reason why we created. And this is why we have installed that Python 3 venv to enable us to create this virtual environment. And to create it, say this Python 3 space -m space venv. So this is the software that we have installed, and here we have to give a name for our virtual environment. I can give a name like my env, or you can give the the standard name, which is .venv. So usually this is named as .venv. This part doesn't change, like Python 3 space -m venv space, this part won't change. Only this is like the name of your virtual environment, so only like this changes. I'll run this. So this should create my virtual environment. Okay, so this is done. So now how to confirm this? Do a ls. It's not showing this because ls would just like show you the files that are not hidden. When you use a dot in front of a directory or a file, it's kind of like a hidden file and hidden directory, right? To display that, type in ls space -a, and here you will see this virtual environment. So we have created it, but we haven't kind of like activated this virtual environment. So we have to do that now. So here I can say source space .venv, the name of the virtual environment, space bin space activate. So this is going to activate that virtual environment. So now we are not using default Raspberry Pi's library. Maybe I'll show this to you. I'll type in this deactivate. So this is going to deactivate my virtual environment. So when the virtual environment is activated, you will see that name of the virtual environment here. That means you are currently using the libraries and the Python that is present in this virtual environment. If I do a pip list over here, right now I'm not in my virtual environment. This is the system's default Python environment. So when I do a pip list, you will see like all the libraries that have been installed. So this is like system default Python libraries that are installed. So I'll clear this, and now I'm going to activate it using the same command, source.venv bin activate. Now this is installed, right? And again, if I do a pip list, this won't have like any libraries apart from pip, because this is like a brand new virtual environment that we have created. After this only we are going to install libraries to it. Okay, so that's the idea. So now we have to install Ollama. You can simply use pip install Ollama. If you want like the exact latest version, search for it here, Ollama pip, and that will take you to this PyPI Python package index site. And from this you can just like copy the version as well, 0.6.1, or you can just copy this pip install Ollama. I'll come back here. I'll say pip install space Ollama 0.6.1 and replace this space with double equal to sign, and that is going to install Ollama with version 0.6.1. okay, so all the libraries are installed, and again when you do a pip list you will see like Ollama that is being installed, and these are like other dependent libraries for Ollama. So yeah, that is about it. So now we have successfully done this. The next part is we can write some code to run this. uh, you can use Nano. So Nano is like a simple file creating and basically a file editor that you can use in your terminal. So I'll say Nano space, let's call this as Ollama chat or something. Okay, again you can give any name over here, that's not important. Ollama.py. So this is going to create a empty file and open it here. So right now we are in this Ollama underscore chat.py. I'll open this PyPI itself. We don't have to code anything different. So yeah, we can copy this code. So this is like we are just like importing this chat module from Ollama and importing this chat response from here, and creating this response which is like of the object of type chat response, and calling this chat model. Basically this sends a query, why is the sky blue, to this Gemma model, and we are sending this to Ollama's chat, and we would get a response, and we finally print it. This is the way of streaming the response, where once you get the token we would kind of like print it over here. So I'm going to copy this code and paste it over here. It's basically we just like do very limited amount of scripting on the servers. Let's consider that this Raspberry Pi board is a server, right? So we don't kind of install IDEs or a lot of applications here. So we would keep this very simple. In real time in projects, what we would do is you would do all the coding and everything in your local. Let's say I'm using VS Code and creating an application. I will check this code into GitHub, and I would connect GitHub within this Raspberry Pi. So basically I code in my local, push it to GitHub, and pull this code to my Raspberry Pi again using my GitHub credentials, and then start the application. So usually we don't do a lot of changes on the board. We don't like code on the board or like any server. So that's one thing. So just for this tutorial purpose, I'm just like copying and pasting this code over here. If not, like the ideal way would be to use a mainly like a SSH and GitHub thing is what we would do. One thing that we have to change this Gemma 2 to Gemma 2 2 billion, because that's the model that we have pulled. We didn't pull Gemma 3, so that's important to run this. So we are again we are calling this chat module from Ollama, creating this stream variable, calling this Gemma to 2 billion model, and sending the user message, which is why is sky blue. So we are sending it over here and saying stream is equal to true. So this is going to stream it. If you want to ask any other different question, you can just like update it over here, and it's going to print it. So this for chunk in stream, this is like it's going to give you the typewriter effect for streaming the response. So that is the purpose of this. So I'm going to save this. For saving this, you will see like all the commands of what you can do with this. To save this, press Control yes. So this would save it, and then press Control X. This should kind of close this file. So now when you do a ls, you will see this Ollama chat.py. If you want to see the contents of this file, type in cat space Ollama. Again, you can type in tab, so that will auto fill it. Press it, and you will see the contents of this file, Ollama import chat and all that. You will see this. If you want to edit it, similarly say nano Ollama and all that. So cat is just like viewable. This is for like editing it. Again, to close this, press Control X. This would close this. I'll clear this. Now we can run our script. So I'll say Python 3. Again, understand that this virtual environment is activated. So it's going to use the Ollama library that is installed in our virtual environment. So say Python 3 space Ollama chat.py. So this is going to send that why sky is blue question, and it's going to stream the response for us. Let's wait for this. Yeah, we can see the response over here. So the sky appears blue due to the phenomenon called relic scattering and so on. So this is how you can pull your Ollama model on this Raspberry Pi board, run a simple script, and just like use that over here. Again, the main advantage is that if you are building some edge applications on some edge devices and so on, you can easily kind of host your local models in case you don't want to use a cloud-based systems and all that. Again, the reason would be sometimes you are working on some private data that you don't want to send to OpenAI or Grok or Gemini or some third-party services. We would just like host some of the OpenAI models by ourselves and we can work on it. One way to think about it is like running this on a Raspberry Pi board, which is like a limited resource computer. So running a smaller model here, it can also be viewed in a way that if let's say some companies would provision a larger machine with let's say 200 250 GB sizes of GPU, but that will be present remotely and you can access it with this SSH and you can similarly write your code over there. So that is the process. So don't just like see this as like a Raspberry Pi implementation. Even if you're running Ollama on an EC2 or you're deploying an application on an EC2 or a remote server, this is basically the process that we would follow. We would SSH into it, pull the code from GitHub, and then we would run it. So this is what I wanted to explain you today, and then I just want to do kind of like more projects on this. So it would be like kind of very a complete project, right? Think about it, like instead of just like running all this on our local, we can just build a complete project, have even hardware to set things up and all that. So I'm planning more projects on that. And again, if you are interested in specific projects also, just like let me know in the comments. I'll see if I can include it. So I can say like deactivate. That's going to deactivate the virtual environment. Okay, can clear all this. I can just like type an exit. That's going to log out from my Raspberry Pi and I will come back to my system's terminal. That's one way. And if you want to shut down this, you can do this remotely as well. I can type in sudo space shutdown. No, so this is going to shut down the Raspberry Pi and I will automatically like move out of that Raspberry Pi. It's like it's been disconnected, the connection is closed and so on. You will get kind of like a C-type charger to power your Raspberry Pi. Make sure that you remove this. When you on it, there will be like a green light blinking, and then once you shut down it, it will turn red. But remove that power supply. Otherwise, like I think the power just keep going into it. So it was like heat management is like one thing that we need to be like very aware about that and all that. So yeah, that's one thing. Again, I probably wouldn't recommend you buying this if you are not going to use it a lot, as it costs like 10,000 Indian rupees. But again, if you are interested in this or if you're working on some projects and all that, this can be like really helpful. Even if you want to like learn to deploy applications and all that, this is like a very good place if you can't like afford EC2 or or something. Again, it depends upon the use cases that you're going to work on, but it would be like a very good practice in case like you want some projects and all that. So this is what I wanted to explain today, and maybe in the later videos we will try to host chatbots in this and then build maybe cool applications with it, and share your thoughts in this comments as well. Like this video and maybe share this with your friends whom you think might be interested in these kinds of stuff. And as I said, I've given the link of my complete generative AI course in this video description, so check that out. That is all from my side, and I'll see you in the next upload. Thanks for watching.